Welcome to Web Development Through Practice. In this second part of our PHP OOPS Concepts series, we will continue from where we left off in part 1. In the previous video, I explained key concepts such as classes, objects, properties, methods, constructors, destructors, access modifiers, inheritance, traits, composition, dependency injection, and interfaces, all with practical examples. We used the example of an e-commerce website. Here, we have a user class that defines common functionalities such as registration, login, logout, profile updates, and retrieving user details. Next, we have an admin class that extends the user class, allowing it to access the common user functionalities while also adding its own unique properties and methods, such as managing users, managing orders, and viewing reports. Additionally, we created a seller class, which also extends the user class to enhance its functionalities, along with its properties and methods related to managing sales and orders. Lastly, we introduced a super admin class that needs access to functionalities from both the admin and seller classes. However, since PHP does not support multiple inheritance, we cannot achieve this directly. To resolve this issue, we initially attempted to use traits, but we found it challenging to convert the functionalities of the admin and seller classes into traits because both classes extend the user class. As a result, we used composition. However, this approach led to difficulties with unit testing the super admin class as it became tightly coupled with the admin and seller classes. To address this, we turned to dependency injection. We also discussed how interfaces could help solve similar problems. However, we noted that interfaces are primarily used to create contracts that other classes must follow. For example, we have a ManageOrders interface with an abstract function named ManageOrders. This interface must be implemented by the admin, seller, and super admin classes. If any class fails to define the ManageOrders method, an error will be triggered. If you haven't watched part 1 yet, I encourage you to do so for a better understanding. In this session, we will discuss how interfaces enable polymorphism, abstraction, encapsulation, and inheritance, along with the definitions of these concepts. Additionally, I will explain static methods and properties, final classes, class constants, and method overloading, all with practical examples. First, let's see how interfaces enable polymorphism. The word poly means multiple and morphism means different forms. In our example, we have a manage order interface that is implemented by the admin, seller, and superadmin classes. If we take a closer look at the admin class, it contains a method called ManageOrders, which is responsible for managing pending orders. In that seller class, we also have a method named ManageOrders, but here it manages processing orders. Similarly, that superadmin class defines its own ManageOrders method, which handles all types of orders. As you can see, all three classes use the same method name ManageOrder but provide different behaviors. This is called polymorphism, having the same method name with different functionalities. Now, why should we use polymorphism? So, it helps to avoid writing numerous if-else or switch statements based on type. For example, consider a filter class that retrieves orders for admin, seller, and super admin. Many developers might define a showOrders method that takes a user type and uses if-else conditions to process the request. However, this is not considered good practice. Instead, we can define the showOrders method to accept any object that implements the ManageOrders interface. This means that you can call the ManageOrders method without needing to check the user type explicitly. For example, if you want to access admin orders, you simply call the showOrders method and pass an admin object as an argument, which will then trigger the ManageOrders method in the admin class. The same applies for the seller and superadmin classes. Thus, you can see that polymorphism promotes code reuse, results in a cleaner design, makes maintenance easier, and improves testing efficiency. Now, in the same example, the interface enables abstraction. Let's see how. First, abstraction means showing only important details and hiding unnecessary things from the user. In our example, we have three types of users: admin, seller, and super admin. Each of them manages orders differently. For example, admin manages pending orders, seller manages processing orders, and super admin manages all orders. We also have a filter class that is used to filter orders by admin, seller, and super admin users. To implement this, we define a show orders method, where we simply call the manage orders method on whichever object is passed. The frontend or backend doesn't care how admin, seller, or super admin manage the orders internally. Users only know that they need to call the manage orders method. They don't need to worry about the internal logic inside admin, seller, or super admin classes. Here, you can notice that we are exposing only the manage orders method and hiding the internal details of how orders are actually managed. This is called abstraction, showing only the important details and hiding unnecessary complexity from the user. Next, we will see how an abstract class can also be used for abstraction. In the same example, we previously used a manage order interface to define a contract for managing orders. Now, let's try to achieve the same functionality using an abstract class. To do this, we create an abstract class file named manageorder.php and define an abstract class using the abstract keyword, like this, abstract class manageorder. Inside this abstract class, we define an abstract method manage orders using the abstract keyword. Remember, an abstract class must have at least one abstract method, and any abstract method must be declared with the abstract keyword and must be implemented by any class that extends the abstract class, so abstract class method must be public or protected. Now, to use this abstract class, we need to extend it in the admin, seller, and superadmin classes. However, here's the problem: the admin, seller, and superadmin classes already extend the user class. And since PHP doesn't support multiple inheritance, we cannot extend the manage order abstract class and the user class at the same time. Now, if we try to convert the user class into an abstract class and define the abstract manage orders method there, it solves the multiple inheritance limitation, because all three classes, admin, seller, and superadmin, already extend user. But we cannot create an object of the user abstract class directly. Abstract classes are only meant to be extended and cannot be instantiated. Also note, abstract classes can have properties and methods with logic, while interfaces cannot. Interfaces only define abstract methods and cannot contain any implementation or properties except constants. Now, the abstract user class works the same as the manage order interface, since it defines the abstract method manage orders, just like the interface. If we look at the admin class, it extends the abstract user class, which means it must implement the manage orders method. Similarly, when admin implements the manage order interface, it is also required to implement the same method. So, if we don't need to create an object of the user class, then we can simply use the abstract user class and remove the manage order interface. The same applies to the seller and superadmin classes. They can just extend the abstract user class and no longer need to implement the manage order interface. Next, in the filter class, we originally used manage order interface for type hinting. Since the admin, seller, and superadmin classes no longer implement the manage order interface, we must remove that type hint and replace it with the abstract user class. This ensures that all objects passed to the show orders method are extend the user abstract class. So, we implement abstraction using an abstract class. However, abstract classes have a few limitations. First, you cannot create an object of an abstract class. Second, we can't use multiple abstract classes in one class because PHP does not support multiple inheritance. For example, a class can't extend more than one class. So, if we need more flexibility or multiple contracts, interface is a better option. Next, let's discuss static methods and properties. These are methods and properties that are defined using the static keyword and access them without creating an object of the class. Means, you don't need to write $admin is equal to new admin. These are useful when you want to share common functionalities among different classes. For example, in a user abstract class, we can define a static method called checkIsOnline using the static keyword. This method checks whether a user is online. Since we cannot create an object of an abstract class, we can access this static method by using the class name followed by the scope resolution operator and the method name. After running the code, you see that we can access the static method from the user abstract class without creating an object. Next, in user class getDetails method, you can use the same static method with the self keyword to check if the user is online, and if so, return the user details. Here, self keyword is used when a static method is defined and used in the same class. Now let's move to the admin class, which extends the user class. In the manage users method, if we want to check whether a user is online before returning the user data, we can access the checkIsOnline static method using the parent keyword. The parent keyword is used to access static methods from the parent class. Similarly, you can use the same static method in the manage orders method and other classes such as seller and superadmin that extend the user class. Next, you can also define static properties using the static keyword. For example, in the user class, you can define a static property called $CompanyName. You can access this static property within the same class using the self keyword. In the admin class, you can access the static property $CompanyName using the parent keyword. So, the benefit of static methods is that you don't need to create an object of the class just to access a single functionality or share common logic. Because creating an object for such a purpose would waste memory. So, if static methods and properties are so easy to access without creating an object, why don't we use static everywhere in an application? Because it breaks fundamental OOPS principles. Let me explain how. For example, we have a user class, originally an abstract class, but let's keep it as a regular class for now. This class contains common functionalities like the register method and the getDetails method. It also has properties such as $name, $email, and $password, which are initialized using a constructor. We create separate objects for user 1, user 2, and user 3, and we call the register method for each one. Everything works correctly. Each object maintains its own data. Now, we create a new class called userStatic. We copy the same logic, but this time we make the register and getDetails methods static. Here's the issue. Inside static methods, we cannot use $this to access properties. As a result, we change the properties $name, $email, $password to static as well. Once the properties are static, we can no longer use the constructor to initialize them. Therefore, we remove the constructor and create a static method called setUserProperties to set those static values. Now, outside the class, we register users by calling setUserProperties method and then registered method. We do this for user 1, user 2, and user 3. Initially, the output may seem correct. We see user 1 registered, user 2 registered. Now, if we try to retrieve user details using the static getDetails method, we will always get only the last user's data, user 3, in this case. user 1 and user 2's data will be lost. Because when we set user 2's data, it overrides user 1's data. Similarly, when we set user 3's data, it overrides both user 1 and user 2's data. In the end, only the last user's data is preserved. In contrast, with the regular user class that uses objects, each user retains their own data because each object keeps its own state. This is why static breaks encapsulation and is not good for storing user-specific data. So, use static for shared common logic like math, helpers, or global counters. Next, let's discuss encapsulation. Encapsulation means exposing only the necessary information using the public access modifier, while hiding sensitive details using protected and private access modifiers. For example, in the user class, we have sensitive information such as the user's name, email, and password. Therefore, we use protected and private access modifiers to hide this data from other classes, preventing direct access. Instead, we provide public methods, such as register and get details, to perform only the required actions. If we still need to access the encapsulated data, such as the user's name or email, we can provide getter and setter methods. Here, a getter method uses to read the value and a setter method uses to update the value. This protects the data and keeps it safe from unwanted changes. Next, let's discuss final class. A final class is defined using the final keyword before the class name. It means no other class can extend it, and this class is locked. Nobody can inherit or modify its behavior. We use a final class to handle sensitive logic, like encryption, security, or payment processing. For example, in an e-commerce website, when a user makes a payment, the system interacts with a payment gateway, such as PayPal Gateway or Stripe Gateway. To manage this, we use abstraction. We have Payment Gateway Abstract class with Process Payment Abstract method. This method is implemented by PayPal Gateway class and Stripe Gateway class. Since user and product details are sensitive data, we need to encrypt this information before sending it to the gateway. To do this, we use Payment Encryptor Helper class, which encrypts the data before it is sent and decrypts it when it is returned. Since Payment Encryptor class handles critical encryption logic, we mark it as final. Because we don't want anyone extending it and accidentally or intentionally changing it. We only want to use it, not modify it. By doing so, we enhance the security of our application and encryption processes. This protects your code from unexpected changes and keeps your application secure and stable. Similarly, the final keyword can be used for methods to prevent method overriding. For example, in a payment gateway class, we define validate payment method that securely validates payment details before processing a payment. Now, this payment gateway class is extended by PayPal Gateway class and Stripe Gateway class. Now, if a developer overrides the validate payment method in PayPal Gateway class and makes changes, such as skipping validation or passing incorrect data, it could compromise the security or integrity of the payment process. So, to prevent this, we mark the validate payment method as final so that no child class can override it. If any class tries to redefine it, PHP will throw an error. And note that we cannot use final for properties, only for classes and methods. In the next video, we are going to discuss some powerful OOPS concepts, such as class constants, method overloading, and key design patterns including singleton pattern, factory method, observer pattern, MVC pattern, and the repository pattern. Don't forget to like, share, and subscribe for more content.